whether the soft copy is available or not, that I don't know. So now, so the subdivision is h equal to 2, k equal to 2 means del x is 2, del x and del y both are same equals 2. The division here is not looking like that, but anyway it is basically both sides same. So a square region is there, so everything is all the squares are there basically. So 2, 4, 6 and then 8. So here also 2, 4, 6 and 8. So basically you have this type of mesh. Now another thing is that the temperature along the edges are not known. Temperature along the edges are not known, meaning by that once we discretize, we have to find the temperature at this point, that is, let us say U1, here it is U2, here it is U3, and then again I have written U2 and U1. The reason behind that the loss of heat is the rate is same, and so the temperature whatever will be here will be same as here according to that symmetry, not the geometric one, because this is also 1 unit from this side, 1 unit from this side, both have the similar type of things. And then if you see 1, 2, 3, 4 unit from the another edge or any edge you take, that since the rate of loss is same, so you can see that this is, if this is U2, this will also be U2. If this is U1, so this will also be U1. Is this point clear? Is this point clear?
Yes, sir.
Okay. So let me complete this part at least first. So if it is U3, then U4, U5, and this again will be U4. This again will be U4. And then U6, this will be U5. Why this will be U5? Can anybody explain? You see its position of U5. Position of U5 is, it is 1 unit from that edge, 2 units from this edge, but both the unit has both the edges has the same rate of loss. So basically it is 1 unit from this, 2 units from this. Same situation is here, 1 unit from here and then 2 units from here. So this also will be U5, this also will be U5. If you see this position, this will also be U5, 1 unit from here and then 2 units from here, or this side, whichever side you take. And similarly, this will be U4, because again this is 1 unit and then 1 unit, 1 unit and then 1 unit, and similarly this will also be U4. Now we'll see this edges things. Here it is U1, so this will also be U1. This will also be U1. I have already talked about this one, that this will also be U1. Then this is U2, this position will also be U2, right? So this is U3, this will also be U3. And similarly, since this is U2, so this will be U2. Is that clear?
Yes, sir.
Similarly on the other side also. So all these variables which I have written, U1 to U6, you have to find out. It is written according to the symmetry. Is that right?
Yes.
Is that right? Hello?
Yes, sir.
Okay. Now, first you write down the central difference approximation for y prime x. Can you tell me what is the central difference approximation for y prime x? Or xk, y prime xk, or yk prime? Yk prime approximation, central difference approximation will be? Hello? Snehbandhu?
Yes, sir. Hello.
So what is that? Central difference approximation for yk prime?
Yk plus 1 minus yk minus 1 by 2h.
minus yk minus 1 divided by 2h. Is that right?
Yes, sir.
Okay, keep that
Yes.
in mind. So basically you require yk plus 1 means for which value yk prime you are finding out that kth position. So you require the one forward one and one backward one to that kth position, right? And then divided by 2 times the step size. Is that right? Is that right?
Yes, sir.
Okay. Now suppose, let me, other things are exactly same. There is no difference. Suppose you want to find out the equation for u1. So what will be the equation for u1? One forward point, one backward point divided by 2 times the step length. So which will be forward point?
U2.
No, that is backward point. Forward point means on the right hand side. If you remember correctly, okay, I'm just reminding back to you people. You write it, take your register, write down the discretization for yk double prime equal to f, means basically y double prime equal to f. I'm talking about your OD. Y double prime equal to fx with, let us say, y prime 0 equal to a. The other end is that also there. If it is y prime 0 equal to a, how will you do that? The discretization for y double prime equal to fx will be what? Yk plus 1 minus 2yk plus yk minus 1 equal to fk. Is that right?
N square of A. Yes, sir.
Is that right?
Yes, sir.
Now, for k equal to 0, what will happen? For k equal to 0, k equal to 0 means what? At x naught.
Yes, sir.
X naught to what will happen? This yk minus 1 will become what? Y minus 1.
Yes, sir.
This is the value which is beyond your domain.
Yes, sir.
Do you remember this thing which we have done for OD?
Yes,
And
sir.
then what we how we eliminate this? We eliminate this from y prime 0 equal to a.
Yes, sir.
How? This will be y naught prime equal to a. What will be the discussion for y naught prime? That is your y1 minus
Y minus 1 divided by 2h.
y minus 1 divided by 2h. This
Yes,
is
sir.
a. Then from this y minus 1 is there, one equation you will get for k equal to 0 from the general discretization. There also you will get y minus 1. Then you
Yes.
eliminate this y minus 1.
Yes,
This is
sir.
what we have done there.
Yes, sir.
Same thing we have to do here. Now, this if you want to write the equation for u1, so what will be that? One forward point, that is a fixed point. That is not in your domain. So let us assume that the domain is extended up to the one more step. You see, I have written here, one more step I have written here, UA, that fixes one.
Yes, sir.
Are you able to see that?
Yes, sir.
So UA minus U2 divided by, so your del U by del X will be, at this edge will be your UA minus U2 divided by 2H, and that
Yes, sir.
equal to 1.5. Is that right?
Yes, sir. Yes, sir.
Did you get the point? Same thing
Yes,
you will
sir.
get if you discretize this del U by del X directly. Del U by del X is there. So U this will be your at that point. So 1 point further, 1 point backward, and then divided by 2h. Right? Is that clear?
Yes, sir.
So from pictorial part, from picture it is very easy. For U2 if you want to write, then it will be UB minus U4 divided by
2h.
2h equal to 1.3. This is a Y part. U2 you can get from Y part, U2 you can get, U2 you can get from X part as well. Because of symmetry. Let me. You see, I have written the fixes values along this YA part. This is UA, this is UB, this is UC, and again UB and UA, right? So basically the domain is the same thing we do there also. We extend the domain, but I mean keeping in mind that those points are not in domain also, right? Left side and right side both sides. Y minus 1 comes if you have the derivative condition on the other side also, means y1a is there for the OD part. Then you get yn plus 1 variable in the equation, and then you discretize that y1 equal to a, y prime 1 equal to a, you get the n plus 1 here also, and then you eliminate that. Do you remember that? Do you remember that? Snehbandhu.
Hello. Yes, sir.
Okay. So is this point clear or not?
Yes, sir.
Now if you want to find out the so u1, u2, u3 you can find out from here itself. From edges, u3 will be uc minus u5 by 2h. That will be
Yes.
equal to 1.5.
Yes, sir.
So u1, u2, u3 we can get from here, and then inside also we will get, because for this u1, u2, u3 we require two equations, because ua is coming, so one more equation is required, right?
Yes, sir.
Okay. Now if you see u5, u5 will be what? u4 minus this will be
0.
no, okay. No, here you are not going to apply, you are not going to apply the derivative one. So this h part is clear, right? And then you have that previous scheme. You have that previous scheme. Previous scheme was that u del square u equal to 1 by h square minus 4 1 1 1 1 everywhere, means minus 4 uij ui plus 1 this is here uij plus 1 uij minus 1 ui plus 1j and ui minus 1j. Is that right?
Yes, sir.
Right. So for this equation, which is in terms of in the form of Poisson equation, what will be the equation? It is del square u equal to q minus q by k. Q and k values are given, right? So this will be what? This will be, once you discretize at general point, this will be what? This will be written like this: minus 4 1 1 1 1 1 by h square uij equal to minus q by k, because del square u, the equation is what? Del square u equal to minus q by k, and del square, that is your Laplacian, del 2u by del x square plus del 2u by del y square equal to minus q by k. Is that right?
Yes, sir.
So this discussion of this part you will get from the earlier one, that is your minus 4 1 1 1, that is 1 by h square uij. Here it is not 0, here it is Poisson type of thing. that is minus q by k, right?
Yes, sir. Yes, sir.
So this will be h square will be multiplied here. So h square will be multiplied here. So this will be your I've already told. This is your the point at which you are finding out. For example, for u5, that will be your minus. Write down the equation, minus 4 u5 plus u4, right? Is that clear?
Yes, sir.
Plus again the u4, the back side, plus u3. Is this clear? Plus u6
Yes, sir.
equal to minus q by k, equal to minus q by k. Put the value of q and k. This into h square also. 1 by h square is there. So minus 4 u5 plus u4 plus u4 plus u3 plus u6 equal to minus h square q by k. Is that right?
Yes,
Is that
sir.
right? H is 2, so this is 1 by 2 square. So this is your minus 4, the value which you for which you want to write the equation, and then along the j side, the previous column value, the forward column value, along the I side, the forward column value, row value, and then backward row value. Is that right?
Yes, sir.
So this is what is there. So you will write, if you this is written for u1. So if you see u1 inside also, so that's what you have to get. Now you have to get two equations. So for u1, if you see one you have got using your derivative boundary condition. Another you will get using the general equation, general discretization. So for u1, it will be u2 minus 4u1 plus u2 plus ua
Plus
plus ua and then
plus
plus
U2.
u2. Is that right?
Yes, sir.
So for u1, you have got two equations. One using the derivative condition. Another you will get using the general one.
Yes, sir.
Is that clear?
Yes, sir.
So that where you have got the ua, you can put the value of ua from the using your derivative one. Is that right?
Yes, sir.
Okay. So now everything is written. The only thing you must understand. Similarly, if you want to find out the general one for u2, so that will be your u4, ub, u3, and then u1.
Yes, sir.
Is that clear? So
Yes,
for
sir.
anyone, you can, for example, u6 is that. So use for u6, you will get u5, u5,
U5
u5, and u5. Minus 4 u6 plus u5 plus u5 plus u5 plus u5 equal to minus q by k. Is that right?
Yes,
H
sir.
square into minus q by k. Minus
Yes, sir.
h square into q by k. So for any variable, you can write down, if you understand this process, then you can write down, if it is the finite number of points are there which you can write, then you can write down the equation very easily. Otherwise, you can give the name according to your ij's, means this will be your how many points are there? 1, 2, 3, 4, and then 5, and then 5 along this, and then 5 along this. So many variables will be there inside variables, and then you will write the symmetry. So that will be more confusing. So you can use the symmetry if at all it is there, and then directly you can write down the equation. So through picture I have cleared. I hope it is clear. And then you can write down the using this formula also those variables. For u1, if it is written minus 4 u1, you can see the next jth column value previous jth column value, and all those things you can put it here. Equal to 1 by h square written here, 1 by 2 square minus q by k is written here, right? So either you write from the picture which you have for that mesh points, or you can write it from the equation itself, discretization. And then wherever UA has come, that has to be eliminated, and that will get eliminated from the derivative conditions. Del u by del y will be your u2 minus ua by 2 into 2 into equal to 1.5, or ua you take on the other side, or u2 minus ua equal to 4 into 1.5, that is 6, and then ua will be u2 minus 6. Is that right?
Yes, sir.
You can put the value of ua here, so that you will get the equation in u2, u2 and u1, right?
Yes, sir.
Similarly, you can do the others one. So is this problem clear?
Yes, sir.
Here I have written ua, everything is written. The only thing you must understand that how it is done. Once you understand that, you will never forget that. Now, once you have got the equations, once you have got, after modifying means putting the value of ua, ub and uc, all these values once you put, then final equations are available. You have the matrix type of equation au equal to b. If you solve using your Gauss elimination, you can solve by LU decomposition, or any other method you can solve by Gauss. I hope now Gauss-Seidel method you must have revised.
Yes, sir.
Okay. So if you use Gauss-Seidel method, then it is called Limmat method. Right? One more problem is given for your Poisson equation. Let me explain that also. This is your del square phi equal to 2. Phi is 0 along all the boundaries, and it is 6 by 8 unit, means your rectangular unit is square, and then h equal to 2 equal to h equal to k equal to 2. So along x side also you have 0, 2, 4, 6, and then along y side it is 0, 2, 4, 2, 4, 6, 8, right? And then since all these values along the edges, they are 0, so accordingly you can see the symmetry very clearly. You can see this 5, 1, 1, 5, 1, 2, and then 5, 1, 5, 3, 1, 5, 3, 2. These are all same. One unit from this edge, 0 edge, another from, because of this all the sides are 0. Is that right?
Yes, sir.
And then only these two variables are there, so these two variables are also same. You see one unit from this 0, another 2 unit from here, 1 unit from this 0, another 2 unit from here. So only two variable, two equations, right? So keep this in mind, never use the geometrical symmetry. Is that right? Hello? 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 Snehbandhu?
Yes, sir. Like there was network issue with me.
There is today that network which seems to be not very good, either here or that side. Okay, so these two problems are clear.
Yes, sir.
Okay. Next is one more method is there, that is your this is called the 5-point method. This is called the 5-point method. If you see the total number of points, are how many points are there? If you see the discretization, that pictorial form,
A11, A12, A21, A22.
1, 2, 4 points along this, and then one more. That is your 5-point. Right? 1, 2, 3, 4, and 5. 5-point formula. 1, 2, 3, 4, 5. Is that right?
Yes, sir.
Now, this is the normal 5-point formula. There is another one which is your diagonal 5-point formula. This one is not here. This is along the diagonal. All the ones are along the diagonal, right? So let me explain that also. If you see the pictorial form, the ones are along the diagonal. Is that right? Did you see this? Whether the slide is visible to you people?
Yes, sir.
So you see the ones, they are in along the diagonal.
Yes, sir.
Is that right?
Yes, sir.
Okay. Now, this derivation or the verification rather I say, I will do the way we have done earlier also. The formula is your uxx, ux plus uxy, that is your Laplacian at the point xi yj equal to 1 by 2 h square. This is the pictorial form. This is the uijth position. So minus 4 uij. See this value? Minus 4 uij, right? Then
Yes, sir.
ui minus 1, j minus 1. This is your I minus 1, this variable, left side diagonal. I minus
Yes,
1
sir.
and j minus 1. Is
J.
that right?
Yes, sir.
And then this will be, if you see, okay, let me see here. I plus 1, j minus 1. This will be your I plus 1, but j minus 1. Bottom one, left side.
Yes, sir. Yes, sir.
Right? And then the other two are I plus 1, j plus 1. So this is the right side, I plus 1 and j plus 1. Bottom right side.
Yes, sir.
Then the top right side will be your I minus 1 but j plus 1.
Yes, sir.
Right? So now the position is clear that minus 4 uij, this position is your j plus 1 but I minus 1, so I minus 1 ui minus 1 j plus 1. This position is your ui plus 1 and your j plus 1. This position is your I plus 1 but j minus
J.
1. Here it is I minus 1 and j minus 1. Is that right?
Yes, sir.
This is called the 5-point diagonal formula. You can verify the error. Error will be order raised to power 4. There also order is raised to power 4. Right? You can put all these values u of x minus h, x plus h, x, and then expand it. I'm leaving this as an exercise. Expand it means in terms of your uxy. So this will be ux. Can anybody tell me the its expansion? It is along the both.
X.
uxy
To
plus minus h
LRC.
times ux ux plus h times ui. Is that right?
Yes, sir. You have
And
to
then
use
similarly,
Taylor formula for two
and then the
variable only.
second term, and like that you can write down the Taylor expansion for all these, and
Yes,
then
sir.
see whether you are getting uxx plus uxy plus this error term or not. So this I am leaving as an exercise. We have done several times this type of thing.
Yes, sir.
Okay. Here is one problem. nothing is there, you have to simply put these things. So this is the Poisson equation uxx. I think this problem is given in that Iyengar book, if I remember it correctly. Uxx plus uyy equal to minus 2, and this 2 plus pi square x 1 minus x cos of pi y. Domain is your x 0 to 1, y 0 to half, right? And then boundary conditions are given as u0y, u1y equal to 0, ux0 equal to x into 1 minus x, ux half equal to 0. Use 5-point formula and 5-point diagonal formula both. Take delta x is 1 by 4, delta y is 1 by 4. The exact solution is also given, right? And then you have to find out the absolute error. Means what is the absolute error? Difference between the value which you have got, and then from exact solution you can find out uxi yj, right, at a particular point, and then you can find out the error. Is that right?
Yes, sir.
So this is here, this problem is you have to do from you have to apply both the methods. Normal 5-point formula and then
Diagonal one.
diagonal 5-point. Is that clear?
Yes, sir.
Okay. So as far as elliptic PD is concerned, it is over, right? So Vardhan is there or not? Snehabandhu? So shall I move further for the parabolic PD?
Yes, sir.
Okay. Adrija? Adrija? Are you there or not? Adrija? Vardhan? Adrija?
Sir, it seems like there's an open IT competition, so both of them are there.
But Adrija joined here. Vardhan I couldn't see, but Adrija I saw that she joined. Okay.
1 minute, sir, I'm asking.
Okay, I will tell one more method. That will be for your parabolic PD. Now, can you see this slide?
Yes, sir.
Okay. So this is a parabolic type of PD. I have already told on the last run that unsteady heat flow is there, diffusion equation is there. So all these equations comes under this. And the form of the equation you may see of this type, that del 2u by del x square equal to your some constant into del u by del t. Normally this is a positive constant, so all these 0, k, these are all positive constants. Del u by del t because it depends on the time, because it is unsteady heat flow, right? So with the time it changes. So that's the reason this del u by del t is also appearing in the equation. So the since it is del 2u by del x square, so two conditions you require for this one, and then del u by del t, one condition you require for this one. So that will be your initial condition. So uxt at t equal to 0 is given as fx. To find the constant which comes from this del u by del t, and then for del 2u by del square, del x square, you require two conditions. So here it is u0t, that is x equal to 0, u0t equal to c1, ult equal to c2, or it may be mixed type of boundary condition. You have already seen that is your either Dirichlet type of boundary condition that you have seen for earlier case, then your this Newman type of or mixed type of boundary conditions. Is that right?
Yes.
Is that right? Now, here you see the equation is your del 2u by del x square and then a constant 0 by k del u by del t. So there is the very first method is basically your explicit method, that is called your Smith method also, SCHMIDT, Smith method. We basically do a very simple thing. We use the central difference approximation for del 2u by del x square and this forward one for del u by del t. That's all. That whatever you get, that is called your Smith method or explicit method. So central difference for del 2u by del x square at xi tj will be this is the notation is used here as uij. Uxi tj I have written as uij. J is your superscript, right? I think in the book the similar way it is written. It doesn't matter which whatever the notation is, whichever book you are reading, if that notation is before starting, you must see the notation of that chapter. So the central difference for this will be ui plus 1j minus 2uij, because it is over I, the central one, ui minus 1j divided by 2 delta x square. This equals 0 by k, and then forward one if you apply for t, this will be uij plus 1 minus uij divided by delta t. Is this clear?
Yes, sir.
After that, whatever the equation comes, that is your called your explicit method or your Smith method. It comes out to be uij plus 1 equal to k delta t by 0 delta x square ui plus 1j ui minus 1j plus 1 minus 2 times k delta t by 0 delta x square uij. Interesting thing here is that if we take this k delta t by 0 delta x square as 1 by 2, then this that is called your actually mesh ratio. It is called the mesh ratio. In the Anger book, the word is used as mesh ratio. So R is this thing equals to half, and this gives a very simple method. That is your uij plus 1 is nothing but the average of ui plus 1j plus ui minus 1j. It becomes very simple. You can apply the problem very easily. Just take the average of the two numbers, and then that will be the variables are available to you. Is that right?
Yes, sir.
So here is the problem that a large flat steel plate is 2 centimeter thick. If the initial temperature that is your uxt equal to 0, right? Uxt at t equal to 0. Initial temperature with the plate are given as a function of distance from one face by the equation, that is uxt at t equal to 0 is given as 100 sine pi x by 2, that is in terms of x, that displacement, that distance Find the temperature as a function of x and t if both the phases are maintained at 0 degree centigrade. Meaning by that U0T is same as U2T because thickness is 2 centimeter equal to 0. So this is the boundary condition. Here is the initial condition. The value of K and C rho, all these are given. Let us take your delta x as 0.25, right? So equation is same, that delta u by del x square equal to k, that you see, what was that equation? K C rho, where is that? C rho by k, right? So if delta x is your 0.25, we have assumed that k delta t by 0 delta x square equal to half. If you remember, just here you have if the mesh ratio is half, where is that gone? If the mesh ratio is half, so this R is half. So k delta t by 0 delta x square equal to 1 by 2, delta x is 0.25. Put that, you will get the delta t turns out to be from here. All these values k, 0, delta x, everything is available now. So the delta t will be 0.206 second. So t naught is 0. T1 will be delta t, that is 0.206 second. T2 will be the next value with addition of 0.206, that is 0.412, and so on and so forth. And then from the equation you will directly get that, because ui1 equal to 1 by 2 ui plus 1 0, the average of ui plus 1 0 ui minus 1 0, right? Is that right? Then you put the value of I equal to 1, I equal to 2, I equal to 3, like that. So it will be your 1 1 equal to 1 by 2 of u2 0 plus u0 0, right? What is this?
0.
u0 0, u x is 0 also, t is also 0.
0.
No. X is 0, t is 0. Both are 0 fortunately here. You see, this is the initial condition also, and this is the boundary condition also at x equal to 0.
Yes,
This is
sir.
your u0 0. Is that right?
Yes, sir.
Now, fortunately here both are same. u0t is also 0, and uxt or x0 will also become 0 here.
Yes,
If
sir.
they are not 0, then if they are not same, then there is a trouble. So there are several ways to do that, but most of the books you will find it is taken as average of the both u0 the boundary condition and then initial condition. There is no particular way to proceed for that. Fortunately here they are matching, right?
Yes, sir.
So this has to be careful. U00 is both the boundary condition and the initial condition. Similarly, you will get the last end also. Once you put I equal to 7, it will be 1 by 2 U80 and U60. Again, this is the last boundary and initial condition. But fortunately, here also both are same. Both are 0. If they are not 0, you have to use
Average.
average. You have to use average, and then you can tabulate the values without much trouble. Being the just average of the two numbers quickly can be calculated. So this is your Smith method. So for today, this much is more than enough, because your exam is also there, and so in this next will be your in the parabolic one. Next is your Crank-Nicolson method, then Difford-Frankel method. So 2-3 methods are there. So that we'll do on the next one, that is on Thursday. Thursday is what date? Thursday is your exam.
Yes, sir.
So Thursday we cannot meet. Okay. So next Saturday at least I can do that this parabolic part. Okay.
Yes, sir.
So for today this much is enough. You prepare for your exam. All the best.
Thank you, sir.